Good afternoon, sir.
Good afternoon, sir.
Can you hear me?
Yes, sir. Yes, sir.
Can somebody tell me last time where we stopped? The probability distributions, where we stopped. Did we do this binomial distribution? Hello? Am I audible?
Yes, sir.
So could you tell me where we stopped last time? Did we do this sum?
We did some sums.
Did we do this one? No. No one knows. No one remember.
Sir, you said you'll start with sum number 12.
What is it?
You said you said to do sum number 12, you'll start with that.
Sum number 12. Which sum? Exercise. Did we do this probability distribution?
Yes, sir.
Huh? We did no?
Yes, sir.
Yes, where? Till where?
Standard deviation, sir.
Standard deviation, no? Okay. Here, no? Yes. Okay, I think last time we discussed, I can't remember because the other sum, the MBA also, we do this one, so I don't know for some time. So now here this, the random variable, we discussed about this probability distributions, and I said that when you say the probability distributions, there are two. One is discrete random variables, the other one is the continuous random variables. So So under the discrete random variables, what you call this binomial probability distributions. So it's like this, I think. So I told that we studied the frequency distributions. And then later the probability and probability distributions. Probability distributions. Then I might have told you that we calculate the mean and standard deviation. So the frequency distributions, now we discuss like this: x bar equal to sigma fx divided by n. So this is to calculate the mean of the frequency distributions. Then for the standard deviation, we use the formula sigma x minus x bar, then u square divided by n minus 1. Here, if there's a f frequency, then here we use the f, then sigma f x minus x bar square n minus 1. This is for the frequency distributions. So now for the probability distributions, how to calculate the mean and variance, and from there standard deviation. For that purpose, I might have told you that x bar, we call it here mean expected value. So it means for the probability distributions, we call it expected value. It means Ex, or we mention by it's a mu, mean. So this is equal to sigma xi pi, pxi, probability. So you multiply this and don't divide by n. So instead of this one, we are using this one, the formula, for the probability distribution. Then for the standard deviation, now we use square root the same way. The square root of sigma x I minus Ex, expected value Ex. Then square and Pi, probability, Pxi. You multiply, but you are not dividing here n minus 1 like here. You don't, right? So this is the way, the formula we use to calculate the standard deviation of a probability distributions. So I think we might have discussed this one, right? So now we will see that how to calculate. Now here the formula is here, expected value or mean of a discrete random variables. Now when you say a discrete random variable, now the random variable you can divide into two. One is discrete, other one is continuous. So when you say the discrete random variable, so I told earlier also, the last week also I told you, it's an integer values. So it means it takes only numbers. I mean, it won't take all the values. Say like 1, say 2, or 3, etc. Like here, X is like here. It won't take like 0.5, 0.7, or 1.2, 1.3, etc. It won't take. But the continuous variable take any value. So that is the difference. So now to find the expected value or mean of a discrete random variable, we use this formula here. Right? I already told you now. The mu or Ex, Xi, Pxi. So when you toss a coin, 2 coins, so you assume that X equal to number of heads. So say 0, it is 0.25 probability. That earlier slides we have discussed this one. So I think earlier here this sum. Now we identified that when you toss 2 coins, there are 4 possible outcomes. One is the both you may get TT, or you may get first one T second H, or first one H second T, or both head. So now if you define X equal to getting number of heads. So now number of heads, there are possibilities you may not get any head, or you may get only once, or you may get both heads. Now there are no 3 out of these 4 possible outcomes. So now only one outcome here, you don't get any head. So it's out of 4, only one. That is 0.25. So now there are 2 possible outcomes. You may get head. So it's 2 out of 4. So it means 0.5. So the answer is now to get the both heads, only one. Yeah. So it's 1 over 4, 0.25. So this is, we call it probability distribution. So what is the problem? What do you mean by probability distributions? So the particular variables in associated probability. So now here, how to find the mean? So you use that formula. You multiply this X by the probability. So now let's go to the here. Here, now it's here, no? So it means X and probability. So you multiply both. Now 0 multiplied by 0.25. So 0 means Xi. Pxi means associated probability. Now here 0 multiplied by 0.25 plus. Why is plus? Because here sigma. You have sigma. So plus, what is the next possibility? 1. It's associated here 0.5. So when you multiply this, 1 multiplied by 0.5. So the next possible outcome 2. So the probability associated with 2 is 0.25. So this is multiplied here. Then when you add all 3, you get it 1. So the mean is 1. So how to find the variance and standard deviation? So the variance, standard deviation, the variance is now here x minus ex square pxi. When you square the variance, you get the standard deviations. So now the same problem, now we can get the we can find the variance and standard deviation. So now here xi 0. Then minus ex, it's a 1. So 0 minus 1 you square multiplied by the associated probability plus. So the next possibility is 1. Possible number of gates. Now 0, 1, 2. So the 1 again minus 1 is square associated probability 0.5. The next one 2 minus 1 square 0.25. Then when you summarize this, 0.5 is the variance. Then square root of this 0.707. So that is the standard deviation. Now let's move here, the next one, the next sum. Ranjit sells new cars for Toyota. Ranjit usually sells the largest number of cars on Saturday. He has the following probability distributions for the number of cars he expects to sell on a particular Saturday. Now the number of cars sold are given here and probability also is given. What type of distribution is this? This is, now you can say this is discrete probability distribution. Why is a discrete probability distribution? So because it takes only 0, 1, 2, 3, 4. So you may say that this is discrete random variable probability distribution. The next one, on the typical Saturday, how many cars does Ranjan expect to sell? Right. So now for this purpose, it is expect to sell means you have to find the EX. So EX, we know that our formula is EX sigma xi pxi. This is the formula. So now we know that this is the x1. No, this column is the x1. This is the probability. So now what we can do is you can multiply this. No, you multiply by 0.1, that is 0. Then 1 multiplied by 0.2, then it's 0.2. Then 2.3, so it's 0.6. Then 3.3, then 0.9. Then next one, 4.1, 0.4. Then when you add, you have a summation here. When you add, you can get it 8, 17, 2.1. You can get 2.1. So this is the EX. So you may say that 2.1 cars not there, but anyway you may say, now you can expect to sell 2 cars. No? You can say 2 cars. You expect to sell on average 2 cars. No? So what is the variance of these distributions? So then what is your formula again? So then you know that is a 2.1 is the expected value. So then we know that our variance, now it's actually a variance, no, not a standard deviation. So the variance is equal to sigma xi minus ex. Ex square pxi. Pxi. No? So this is the formula, right? So now we can find here, now we can put the next column here. Now xi minus ex, u square, then pxi. No? So now we can write it here. We know that already we found the ex 2.1. So therefore we can say xi 0, then minus ex we have found 2.1, then u square, then multiplied by 0.1 equal. The next one 1 minus 2.1 u square, then multiplied by 0.2 equal. The next one 2.1 square into 0.3. The next one 3 minus 2.1 square into 0.3. Then 4 minus 2.1 square into 0.1 equal. So then you have to add all these. You have to find the answer. So what is the answer? Anyone tell me? No. So you have read all these things. There was a small mistake here. It should be 1.29. Then here the standard deviation is square root of 1.29. Now shall we do number 1 here in your exercise? Exercise, Nimal, who frequently invests in the stock market, carefully studies any potential investment. He is currently examining the possibility of investing in the Trinity Power Company. Through studying past performance, Nimal has broken the potential results of the investment into 5 possible outcomes with accompanying probabilities. The outcomes: annual rates of return on a single share of stock that currently costs rupees 150. Find the expected value of the return for investing in a single share of this company. So the return on investment is given percentage, 0%, the probability 0.2, getting the 10% return, 0.25, 15% 0.3, 25% 0.15, 50% 0.1. So if Nimal purchases stock whenever the expected rates of return exceeds 10%, will he purchase the stock according to this data? Calculate the standard deviation. So therefore, can you please calculate the expected return and standard deviation? Send to me. Only one instrument is sent. What about others? If you don't understand, ask me. Amasha, what is the answer of S1? Expected value. Now here, many are done here. Now here, return on investment, this is the X, no? This is the X, this is the PXI. So now you multiply both, no? Now we know that the EX, we have to find the EX. You have to find the EX equal to this column, no? This both you have to multiply, means XI PXI, no? So when you multiply, it's a 0. Then plus you multiply this both, then it is 2.5. Then you multiply this both, then 4.5%. Then plus, then multiply this. Then it's 3.75. Then here it is 5%. So that is equal to 15.75%. So this is the answer, the expected return. So you have to tell that if Nimal purchased stock whenever the expected rate of return exceeds 10%, will he purchase the stock according to this data? So now here the information, the given information says, now he will purchase, Nimal purchase whenever the expected rate of return exceeds 10%. So of course, then since 15.25 exceeds 10%, you have to say that he will purchase the investment. He will purchase the investment or the stock, no? So then, according to this data, calculate the standard deviation. Now most of you have sent it. That is 13 point. Like earlier, you can calculate 13.71%. If you have any doubt, you can ask me. Now the number 2, the manager of the large computer network has developed the following probability distributions of the number of interruptions per day. This is also similar. So compute the mean or expected number of interruptions per day. So you have to multiply this both column and add. No? So then you can get the answer. So from there, you also can calculate it. You can compute the standard deviation. Then you can do as a homework. Number 3, also similar. Now in this case, now you have to convert into, this is given as a frequency. Now if you want to use this as a probability, then you have to convert into relative frequency. So the relative frequencies means, so now here the total, out of total, now the 30 divided by, then the total. Total is how many? I mean, you have to find the total of these, no? The total here, no? You had all in 13 divided by the total, then after that 25 divided by the total, then after that you can find the expected number in standard deviation. So the same way, number 4. The number 4, this is you are trying to develop a strategy for investing in 2 different stocks. So the anticipated annual return for $1,000 investment in each stock under 4 different economic conditions is the following probability distributions. So now you compute the expected return for stock X and for stock Y. So now in this case, now we have a probability here. Now depending the economic conditions, if it's recession 0.1, slow growth 0.3, 0.4, 0.2. So but anyway, whether it's stock X or Y, the probability is similar. So therefore, if you want to find EX or ER, you may say expected return ER. So then what you have to do is, then you have to multiply this minus 50. So you have to say the minus 50 into 0.1, then plus 20 into 0.3, then plus 100 into 0.4, then plus 150 into 0.2. Then you summarize, you will get the answer. Then if you want to find, this is for the x, for the y, this is for the x. Then for ERY, expected return y, so this is equal to, so this y column, say minus 100 into 0.1, then plus 50, the probability one change 0.3 plus, then 130 into 0.4 plus 200 into 0.2 equal. So when you summarize, you may get it, the EX and EY. The standard deviation also now you can find from here, no? So from the particular ER, you find the difference and you can find it. So the standard deviation also for X and Y. Then would you invest in stock or stock Y? Then explain. So please do this homework, and if there are any issues, you can ask me. So now I go to the next one. If you have any doubts, you can ask me, or you can type at the chat box. So the next come to the binomial probability distributions. You know, there are two types of distributions. I told you, one is discrete probability distributions. Other one is the continuous probability distributions. So under the discrete probability distribution, there are two distributions. This we call it binomial distribution. Other one, the Poisson distributions. So now we will discuss what is the binomial distributions. So now here, the binomial probability distribution is widely occurring discrete probability distributions. So why you are calling it a binomial? So this one characteristics of a binomial distribution, there are only two possible outcomes. So as an example, you sit an exam, only two outcomes. You may pass or fail. No, only two outcomes. You pass or fail. No. So when you produce a product, it may be good product or bad product. No. So maybe it's acceptable or not acceptable. So likewise, when there are two outcomes, or for a particular event, now you may use this binomial. You call it binomial. So since these two categories are mutually exclusive and collectively exhaustive, when the probability of the event of the interest is represented as P, then the probability of the event of interest not occurring is 1 minus P. So now if you say that you will pass the exam, say 0.6%, it means 0.60%, it is 0.6. So then not passing the exam or failing, so then it is 1 minus P. 1 minus P. So it's equal to 0.4. So that's what you say, that these two categories are mutually exclusive. Now you cannot pass and fail the exam. Or a product can't be good and damaged. No, either it should be good or damaged product. So therefore it's mutually exclusive. Then why you are calling collectively exhaustive? If you say that if you are producing like 100 goods, all hundreds either should be either good product or bad product. Somewhere should be. That's what we call it collectively exhaustive. It means total should be equal to 1, like probability equal to 1. So the binomial distribution, probability distributions, now to calculate, you always assume that there are X number of observations, N. Right? So example, now when you toss a coin, say 15 tosses of a coin, so it means a fixed one. Right? So or you make it 10, so whatever it is a fixed one. So then when you test for a, say 10 light bulbs taken for a quality check, taken from a warehouse. So this 10 light bulbs is a fixed one. So always this N is fixed. N is fixed and you define N. Then it's a constant probability for the event of interest occurring for each observation. So if there are 15 tosses, for each toss, the probability for the event is constant. It cannot change toss to toss, or bulb to bulb, or product to product. It can't change. So it should be constant. Means the probability of getting a tail is the same each time we toss the coin. Right? So that's what it's constant. Next one, observations are independent. So it means the outcome of one observation does not affect the outcome of the other. Right? So it means once you toss a coin, the outcome you may get head or tail. So second time when you do, there's no any effect from the earlier one because it's independent. Right? So the outcome of one observation does not affect the outcome of the other. Now the possible applications for the binomial distributions. So the manufacturing plant labels items as either defective or acceptable. These are some examples where you can apply this binomial distribution to find the probability. Or a firm bidding for contracts will either get a contract or not. Or maybe a marketing research firm receives survey responses of yes, I will buy. Always two outcomes. No, I will not. Yes or no. Or new job applicants either accept or reject. So that's what we call it binomial distribution. No, you can apply when there are only two outcomes. No, two outcomes. One is we call P, other one is 1 minus P. 1 minus p. So the total probability should be equal to 1. Okay. If there are any doubt, if you have any doubt, ask me. So now these binomial distributions, the counting techniques. Suppose the event of interest is obtaining heads on the toss of a fair coin. So you are to toss the coin 3 times. As an example, in how many ways can you get 2 heads? So possible ways HHT, HTH and THH. It means how many ways can you get 2 heads? So there are 3 ways you can get 2 heads. So the situation is very simple. But we need to be able to count the number of ways for more complicated situations. So in such a situations, now you have to use a formula. So this is what I told, we have studied earlier the counting techniques, the number of counting techniques. So when it comes to the, here I told permutation and combinations, last lecture, combinations. So the number of combinations of selecting x objects out of n objects is NCX n factorial divided by x factorial n minus x factorial. So n factorial n minus 2 and 2. No? Okay. Now I am going to ask some questions. No, I think now you have to tell. I will ask a person, anyone, then you have to tell, right? To test this one, right? So now two factorial equal to, now I am going to ask, now I will ask Madhusani, if yes or no, it's okay. Can you tell me the answer? What is the value? Madhusani, you are there?
Yes, sir. I'm here.
Yeah, what is the answer for this? Two factorial equal to 70. 70, you are there?
Yes, the answer is 2. 2 into 1. 2.
Very good. 2 into 1. No? That is that?
Yeah.
It's a 2 into 1. Is equal to 2 into 1. So, this is equal to 2. What is the answer? It's a 2. Okay? So, now I am going to ask another one. 0 factorial equal to, I am asking Kaviraj. Kaviraj, are you there? If you don't answer, no problem. You say whether you are there or not. Kaviraj. Kaviraj, you are there? Number 22. Not there. Viduranga, you are there?
Yes, sir.
Hello?
Sir.
Viduranga, tell me what is the answer 0 factorial equal to?
0.
No, that's wrong. Have you come last week? Here
Yes.
is there, no. Answer is there, here down, you see here. Screen. Are you sleeping? Now it's there, no. You are telling 0. 0 factorial equal to 1. Last time also I told you, no. Always 0 factorial equal to 1. So eraser, tell me 1 factorial equal to. 1 factorial equal to eraser. Rest of all, tell me, eraser, are you there?
Yes, sir. 1 factorial equal to 1 factorial equal to 1.
1 factorial equal to 1. 1 factorial equal to 1. So eraser, tell me 1 factorial equal to 1. 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 1 Yes or no?
Yes, sir.
No.
I'm here, sir.
Kusan. Kusan, you are there? Why these people know?
Yes, sir. I am.
Then you want to tell why you are getting late. So what is the answer? One factorial equal to? So no point no here. I am teaching here, I am talking to the screen, you all are sleeping, or I don't know what you do. No, I don't know whether you understand or not. I understand now, you don't understand anything. Except a few students. So last time, how many times I told you? 1 factorial equal to 1. No, always. 0 factorial equal to 1 by definition. 2 factorial equal to 2 into 1, 2. So somebody else tell me, I will ask, no one tell me, 5 factorial equal to 5 factorial equal to Gunadilake. Why is Gunadilake? Are you there?
Yes, sir.
Yes. Tell me that what is the answer? You can take some time. Gunadilake, you have to tell this one, then I will give another one. There are no names now. Nayendra, are you there?
Yes, sir.
Nayendra is there?
Yes, sir.
Hello?
Yes, sir.
Yes. 4 factorial. You have to tell me what is the value? 4 factorial. Now, if you don't understand this, then you can't find the binomial distribution. No, the answer.
Oh,
4 factorial. What about the 5 factorial?
120.
20, sir. 120.
Now, 5 factorial equal to what? 5 into 4 into 3 into 2 into 1. No? So it means 20, 60, 120. No? So 120. Now she told the answer, no? Okay, good. Other one, 4 factorial. 4 factorial means what? 4 into
24.
24.
Sir.
4, 24, no? It's a 24. Okay. So this is the way we try to find the factorial. Right? So this one we apply in the binomial formula. The binomial. So now this is okay. Now these applications. Now as an example, how many possible 3 scoop combinations could you create at an ice cream? If you have 31 flowers to select from. So how many are there? In this 31. You select 3. No? So these combinations 3, 31, 3. So that is equal to n factorial, no? N factorial, 31 factorial. Then divide by x factorial, x is 3. Then n minus x factorial, no? So when you summarize this, you get 4,495. So this is the binomial formula. So when there's a binomial distribution, now how to find the probability? How to find the probability? X is a variable. What is this variable? This is the variable discrete random variable. It's not the continuous variable. Okay. So this is the formula. No, this is the counting process. The formula one part. So then here is a p to the power x. Here 1 minus p to the power n minus x. So the px indicates probability of x events of interest in n trials, with the probability of an event of interest being P for each trial. So as an example, when you flip a coin 4 times, N becomes 4. P becomes 0.5. Why 0.5? When you flip a coin, you may get either head or tail. Right? So it's a 0.5. So what is the 1.1 minus P? The balance 0.5. So now when you flip a coin 4 times, what happened? All the 4 times you may get the head. So you have defined x as a number of heads. All the 4 times you may not get head. All 4 times you may get tail, no? T. Or only once head, 3 times tail. Or 2 times head, 2 times tails. Or the 5 you can't get it, no? Because only 4 times you do. But here if it's a 5 times you toss, then 5 also come. 10 times you toss, the 10 also may come. Right? So then how to find the probability? No? Because you can apply here binomial formula, no? Because only 2 outcomes, head or tail. Right? So now let's go to the next one. Next slides. Here. What is the probability that one success in 5 observations? If the probability of an event of interest is 0.1, so it means P is 0.1. N is 5 at the 5 observations. So you are going to find x equal to 1. If P x equal to 1. What is the probability that one success in 5 observations? Now if it is a 2, you x equal to 2. No? So now this is the formula. Yes, the formula. Then you just substitute the values. No? N is 5 factorial, so 5 factorial. X is here, no? 1 factorial. Here, no? 1 factorial. X factorial, 5 factorial. Then n minus x, 5 minus 1 factorial. Then p 0.1 to the power 1. Then 1 minus p, 1 minus 0.1 to the power n minus x. It means 5 minus 1. So when you summarize this, your probability is 0.32. Right. So now this is the way we try to find the probability for the binomial probability distribution. Now we take another example. Suppose the probability of purchasing a defective computer is 0.02. Defective computer is 0.02. So what is the probability of purchasing 2 defective computers in a group of 10? 10 means it's a fixed number, I told you, no? It's n is 10. N is 10. Okay? So you 2 defective, it means x is now you, what is the probability that purchasing 2 defective computers? Then it's x equal to 2. What is the probability that purchasing 4 defective computers? Then it should be x equal to 4. Then what is the probability that purchasing defective computers less than 2? Then it may be less than 2 means maybe 0 or 1. Right? So now in this case only 2, it's a 2. So then n is then factorial. You substitute the values. Then x2 factorial, here n minus x factorial, 10 minus 2 factorial. Then your probability, now you try to find the defective computer. So the probability for the defective computer is already defined, 0.02. So if this is 0.02, then 1 minus p, the balance, no? It means 0.98, no? 0.98 here, no? So you just substitute the values, p 0.02 to the power 2, then 1 minus 0.02 is a 0.98, 10 minus 2. So when you summarize, your answer would be 0.01531. So the binomial distribution same. So this binomial distribution, shape of binomial distribution depends on the values of p and n. Right? This one, p and n. So now in this case you look here, n is 5, p is 0.1. So when you find the probability that your shape will go like this, but this may change when your p change. Now you see the next one, n not change, but p change, probably change, 0.5. Then it becomes like a normal, no? It comes like this. So if there is another one, say p equal to 0.7, then the shape may be different. So what you have to understand is, now when the p change, the shape of the binomial distribution change. So this binomial we also can find using binomial distribution using binomial tables. So we may use formula to find the probability for any values. But using that formula, so there are some tables, binomial tables. So, but the binomial tables you can't find for all possible values. Now, as an example, now this table is developed for n equal to 10. But what happened n equal to 8? This table is not useful. No, you need another table. So, but anyway, if you have a table, then now p point to, now this is here in this book, now they use the pi, yeah, sometime. In some books they use pi, no? Instead of p, no, this is equal to p. Equal to p. The symbol, no, anything you can use. No? So if you are using pi, they may use for 1 minus pi, no? In your formula. No, earlier we used in the formula p. So 1 minus p, no? Like this. So I purposely gave this because now if you, when you read some different books, they might use this. So now your probability here, the interest of the probability of the interest is 0.2, if you know, right? So then if x is equal to 3, then what is the answer? Now you look here, this is the answer. You don't need to calculate, already there. Now if your n is 10, you see your p 0.35, then if you want to find x equal to 3, then the answer is just you get it here. This is the answer. So if it's 2, it is the answer. So you get the answer directly from your binomial table. Also from Excel software also you may find very easily giving this number if you want to calculate the probability. So the characteristics of the binomial distributions. Now we studied mean of any probability distribution. We have a common formula. Now just before we studied EX, how to calculate the EX. Now we know XI, PXI. No? What you do is you multiply all these XI column by PXI column and you find. But if you this X is binomial distribution, your distribution binomial, you don't need to use this. How you calculate directly multiply by P, then you can get it. That is the characteristics. No. So then how to find the variance standard deviation? Now we know how we are finding X minus EX minus EX minus EX, then you square, then PXI. This is for the variance. Then when you square out this, find the standard deviation. But if your distribution is binomial, then simply what you do, NP multiply by 1 minus P. Then standard deviation square root of NP 1 minus P. So here, if n is 5, p is 0.1, then EX 0.5. So for standard deviation here, 5.1, 1 minus 0.1, then square root, this is the standard deviation. So likewise, when you change also 5.5 to 0.5. So likewise, standard deviation 1.118. So now before we go to the Poisson distributions, now we will do a sum from our exercise. Now look here, number 5, Davidson, Director of Quality Control for the Tokyo Motor Company, is conducting its monthly spot check of automatic transmissions. In this procedure, 10 transmissions are removed from the pool of components and are checked for manufacturing defects. Historically, only 2% of the transmissions have such flaws. Then what is the probability that the Davidson sample contains more than 2 transmissions with manufacturing flaws? So now here we may apply binomial distribution because now you have defects. Now you try to find the defect, manufacturing defects of the transmissions. So now in this case, now we know n equal to 10. N equal to 10. We also know P, or you call it pi, whatever, or you call it pi. This equal to 0.02. Then we know 1 minus P equal to 2%. So So it is 0.98. Then your x may be 0. It means no any defective item possibility, no? Maybe 1 or 2, then up to 10. No? Up to 10 it may go. So now you who are supposed to find what is the probability that Davidson sample contain more than 2 transmission. More than 2 transmission. So in that case, your x, you have to find x more than 2, more than 2, more than 2, x more than 2. More than 2 means what? It will be 3, O means plus, no? 4 plus 5 up to 10. So you have to find for each and you have to add. Or alternatively, what you can do is this equal to 1 minus, because the total prop is 1. P x equal or less than 2. Equal or less than 2. This would be similar. This would be similar. No, this would be similar. This way or this way. So now if you find this, your work is less. Why? Now you may find P x equal to 0, then plus P x equal to 1, then plus P x equal to 2. Right? So then after you add all these things, you deduct from 1. Then you can find the answer. So now how to find the answer? Now first of all, we will find here P x equal to 0. So this is equal to now so can you see this blackboard? Whiteboard? Hello?
Yes, sir. Visible.
But there are some problems here, I don't know. So now this is the formula here. Then P to the power x, then 1 minus P to the power n minus x. This is the formula. So this is equal to, we know here, n factorial equal to 10 factorial. Divide by x factorial here 0 factorial, no? Here 0 factorial. So now here 10 minus 0 factorial. Then p we know 0.02 to the power 0. Then here 1 minus p 0.98 to the power 10 minus 0. So then this is when you summarize 0 factorial equal to 10 factorial, 0 factorial equal to 1. Here 1. So then 10 factorial divide by 10 minus 0 factorial, here 10 factorial. Then this equal to 1. This equal to 1. Now the other people also here drawing. So how can I do the sum? So that's what I am trying to stop this. No? So then 0.02 to the power 0 also 1. Then when you find the 0.98 to the power 10, you will get the answer for 0. Right. Now x equal to 1. Then now you have found the answer for 0, x. Then after that for 0, 1. And also 2 you have to find. Look. Then for the 1, how to find it again? So it means 10 factorial divided by x factorial. No? X factorial n minus x factorial. This is a formula. This is our formula. No? So 1 factorial, then 10 minus 1 factorial. So this is equal to 10. How you get the 10? 10 minus 9, etc. It goes 10, 9 factorial. Then divide by 9 factorial. 10 minus 1, 9 factorial. Then this one get deleted. Then answer you will get 10. Then into p to the power x. So it means into 0.02 to the power 1. Then into 0.98 to the power 10 minus 1. So it means 9. No? It means 9. So when you summarize this one summarize, you will get an answer. Right? So similarly, then you may get for 2 also. 2. Now 2p x equal to 2. So that also here 10 factorial. Then x is 2 factorial. Then 10 minus 10 minus 2 factorial. Then here P 0.02, 0.02 to the power 2, then 1 minus P means 0.98 to the power 10 minus 2. So when you summarize here, at upon here 10 into 9 into 8 factorial, then divide by here 2 factorial, 2 into 1. And here 10 minus 2 factorial equal to 8 factorial. So this we can delete. Then here also 5. Then your answer would be for this would be 45. Then it's point into 0.02 to the power 2, then into 0.98 to the power 8. So then you will get the answer. So now you have 3 answers. What are the 3 answers now? Now you have 3 answers. One is P x equal to 0. With the formula you have found the answer. Then Px equal to 1. You have the answer. Then P x equal to 2. You have the answer. So then you add all these 3. Then I said that earlier 1 minus, you deduct this answer. So now you have to deduct here from 1 minus, then it's the total. So then you can get an answer. Are you clear now? Is there any issues? No issues. So please do it and come next time. Here, this is and also this is the answer. This one. What is the probability that none of the selected transmission has any manufacturing flow? This already you calculated that here, no? So it means now you have to find here P x equal to 0. X equal to 0. That already you found here, no? To answer here, you found, you can give that answer here. So then if 500 such samples are investigated, find the expected number of samples with 2 transmission with manufacturing flows. The 2 transmission with, so it means now we found P x equal to 2. For here we found the answer. You have an answer. Now this is the probability. So how to find the expected number? Now expected number I told how to find here Ex equal to NP. NP. So N means 500. Probability, whatever you find the answer here, please do it as a homework. Then you multiply. That would be the answer. Then none of the selected transmission has any manufacturing flow. So it means here. Whatever answer you find here, I think that is 0.98 to the power 10, no? So this answer you multiply by like this 500. 500. Here, no, it's a 500. Then multiply that this one to find the expected number. So please you try to do and come next time. So I can't take further. I think today I am going to stop with today. So we will meet again next week. If you have anything, you can ask me.